Welcome guys in this new lecture of quantum computing using Python. In today's lecture we are going to continue from Pauli's X gate. In today's lecture we will see what is Pauli Y gate. So Pauli X gate, as we learned in previous lecture, is nothing but not logic gate implementation. Talking about Pauli Y gate, it is fundamental single qubit gate that flips the state of a qubit by rotating it by 180 degrees. And it serves as the building block for more complex quantum gates and algorithms that plays an important role in quantum error correction protocol. The code is going to be pretty simple. We will be doing simple modification. We'll be writing here y instead of x, and that's it. And let's run this. So here you can see this is y. Earlier it was x, but you can see the phase change is not clearly visible with this simple code. For that we need another way to represent, and that is called a state vector. So a state vector is a complex vector that represents a state of qubit in this given form. So again, this is alpha 0 plus beta 1, and this introduces a phase of I, or that is 180 degree phase shift, or phase information and amplitude information. Both will be mentioned if we use a state vector. So let's see how to do this thing using code. For that I'll be using one simple library. Let me just write it here. So that library belongs to Qiskit, and it is called Qiskit dot. So let me write here Qiskit dot, and it is called quantum underscore info. So you can see here it is quantum underscore info, and from here I'll be importing a state vector. So again, just take care of this case sensitivity. So state vector. So this is the library that will be helping us to visualize our phase change or flip of the state of qubit. So let's use this. I am taking one variable state, and I am writing a state vector. Sorry, state vector dot from underscore instruction. These things are auto prompting here, but it is usually a good practice to write it rather than just shift tab it here. So QC. Now this will help me to visualize, and it is again not necessary, but just to visualize the flip or the theory that we just saw here. So let's print this. I'm just writing one message state vector. It is not compulsory. You can directly print and see the state vector changes here. And state. Okay. Now you can see here the state vector. So this is 0 plus 0j and 0 plus 1j. So you can see here this is equivalent to this thing here, and it is actually we are getting the amplitude and phase information simultaneously. Earlier it was not possible using simple logics. So this is what all about Pauli's Y gate. In next lecture we'll see Pauli's Z gate. Thank you.